Trigonometric functions and right triangle, 12.1. In this video, we're going to talk about the introduction of trigonometry, specifically in right triangles. So to do this, we need to know what a right triangle is. And a right triangle is a triangle with one right angle. So the next thing to do is the most important step, is you got to know how to label your triangle. So it's the first thing I do. I still do to this day. Every time I look at a triangle, I label the sides in my head. So to do this, we got to start with what the angle is. So in this case, we're talking about angle B, as you can tell by the fact that there's a little theta there. Theta is just a variable for angles, just like x, y, z. In angles, we like to use theta, Greek letters. So that's our angle. So opposite of that side, opposite of this angle is, we call it opposite. Right, so here's my angle. On the opposite side is opposite. Next, you find the right angle, right here. On the opposite side of that is what we call the hypotenuse. It's the longest side. That's me highlighting, not boxing it out. And then so you have opposite, you have hypotenuse. Then the last thing is adjacent. Adjacent means next to, and it is next to the angle, so that's how you can remember it. But mostly it's the remaining one. I always start with my angle. Okay, and the opposite side is opposite, and then we have hypotenuse and adjacent. Now that we know how to label the sides, the next thing we're going to do is how to talk about the ratio of the sides. How we talk about opposite hypotenuse, opposite adjacent. And we call that our trig functions. So there's 6 of them that we know. The first here are the most important, and that is sine, spelled like this totally, cosine, and tangent. The reason I write them out because we rarely ever write them out, but I do want to show you that that's the way they're actually spelled. Sine, we write like this for short. It's not sin, it's sine. Cosine, we write like this for short. And tangent, we write as tan for short. So those are the first 3 trig functions we're going to focus on. Now sine, let me erase this and rewrite it real quick. Sine is known as the opposite over the hypotenuse. So here's my angle. Sine's going to be the opposite side, right here. Over the hypotenuse side, right here. Cosine's the next one. Cosine equals the adjacent side over the hypotenuse side. And then finally we have tan, which is the remaining, the last one, opposite over adjacent. So opposite over adjacent. Now those are the most important 3 trig functions. We got sine, cosine, and tan. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. And you have to memorize these. We use them all the time. For the rest of the math career, we're going to use them. So you have to know them. Luckily, there's an easy mnemonic that I love, that I use all the time to remember this. And I'm sure you guys heard it before. It's called SOHCAHTOA. So it's SOHCAHTOA, where we have sine, which is opposite over hypotenuse. Let me get this down first. I need the A. Color coding is hard, or time consuming at least. There we go. So SOHCAHTOA. And it's just like it sounds. If you know how to spell it out, it's so opposite over hypotenuse. Sine is opposite over hypotenuse. Cosine is ca. Cosine is cosine is adjacent over hypotenuse. And tan is toa. Tan is opposite over adjacent. So if I had a thing here and I was like, let's put numbers here, like 1, 4, and radical 17. I was asking, what is tan? You just go, it's opposite over adjacent. It's 1 over 4. It's 1 over 4. That's really it. You're done. That's the ratio of the sides. The ratio of this side to that side is 1 over 4. So those are the first 3. Those are the most important ones. Those are the ones you have to know. To know sine, cosine, tan. Now we have these other trig functions that we're going to learn about, reciprocal trig functions. And those are, so you have sine, cosine, tan. We're also going to have cosecant, secant, and cotangent. Now for short, we write this as CSC of theta. Remember, theta is just a variable. you never just have sine. By the way, you never have sine, cosine, or tan by itself. It's always with the variable. So it's cosine of this thing, sine of this. It's like very similar to natural log and log. It's always with the variable inside. Secant, SEC, and cotangent, you write as cot, COT. Now, the reason these are more important is because these are just reciprocal functions. They all connect. If you know what sine is, you're going to know what cosecant is. All we're going to do is flip it over. Cosecant is 1 over sine, or hypotenuse over opposite. I'm done with the color coordinating for now. Right, and then cosine is opposite, is reciprocal of secant. It's just a reciprocal, not opposite. 1 over cosine, or just flip it, hypotenuse over adjacent. And then tan goes with cotan, so this is the same as 1 over tan, or adjacent or opposite. So those are the 6 trig functions. Again, the most important thing to know is sine, cosine, tan, SOHCAHTOA. I'm going to say it over and over and over again, because SOHCAHTOA is amazing. And then now you got to know the reciprocal functions. Now, easiest thing to do is don't memorize these. Memorize these 3, and then just flip it. That's all you have to do. Memorize these and flip it. Now, the hardest thing is that it sounds like sine should go with secant and cosine should go with cosecant, but it doesn't. So just remember, those are flipped. That's probably the easiest way for most people to just flip those 2. Because I know that doesn't sound proper. Tan's easy. Tan goes with cotan. That makes sense. These 2 don't, because life is hard sometimes, I guess. Not for real problems. So after we have that, let's move along. Let's do the example here. So we're gonna find the value of the 6 trig functions of angle B. Now notice it wants angle B. At angle A, it has a little thing there. It's trying to trick me. It wants angle B. So let's label angle B here. Remember, the first thing we do, anything around the paper, the first thing we do in our head is label the sides. So first, I'm gonna label this side. Opposite of B is gonna be opposite naturally. Here's my right angle. So opposite that side is hypotenuse. And the left one is adjacent. Now I'm gonna do the first 3 trig functions first. So I'm gonna go SOHCAHTOA. As long as you know how to spell this, you're good. Sine of B is opposite of hypotenuse. Cosine of B is gonna be adjacent adjacent right hypotenuse. Thought about it for a second. Tan of B is going to be TOA, opposite of adjacent. And now once I figure out those, I know the reciprocal functions, because sine, remember, it goes with cosecant. So cosecant of B, cosine goes with secant of B, and tan goes with cotan of B. Now I'm not always going to write it like this. You're going to have to find it yourself, or I might write it and mix it up for you just to mess with you. Haha. But anyway, let's do sine, right? Sine is opposite over hypotenuse. So it's just 15 over 17. And since I know sine, cosecant is opposite, is hypotenuse over opposite, so we just flip it. And leave it like that. We like improper fractions. Cosine, adjacent over hypotenuse. So adjacent over hypotenuse. So 8 over 17, which makes this 17 over 8. And then tan is TOA, opposite of adjacent, 15 over 8. And this is 8 over 15. And that's how I find the 6 trig functions if I give you a triangle, right? Just label the sides, SOHCAHTOA it, and then you're good. By the way, if I would have done it for A, let's look what sine of A is. Well, sine of A, that kind of changes the whole board now, right? Now that is opposite. 8 is opposite. Hypotenuse is still 17 though, because that doesn't change. Sine of A will just be cosine of B. It makes sense. This is opposite adjacent. When we talk about B, that's adjacent hypotenuse. Point there out the wrong thing, but that's the idea. This little thing just says, hey, notice that the reciprocal functions? Yeah, I said that already. Thanks for being behind. Next is a little trickier. They tell you what tan is. They want you to find all the other ones. All you have is tan. So what we do here is we do this. We draw it. Draw a triangle. Then we're going to SOHCAHTOA it up to fill out the sides. You can spell fill sometimes. Out sides. And then we'll finish that up because there's a special thing we're going to do that we haven't done in a little while. So I'm just going to draw a triangle. get used to this. We're going to draw lots of these. It's going to be a right triangle. Let's say this is B. Doesn't really matter. Now I'm going to label my sides. Remember, if this is angle B, that makes this opposite, because it's across from it. Here's my right angle, so that's hypotenuse. This is adjacent. Now, how do I fill out the sides? Well, I know something. I know tan is 3/7, and tan is TOA. So opposite over adjacent. Opposite has to be 3. Adjacent has to be 7. And then if I have two sides of a triangle, remember how to find the third side? Think back to geometry. Famous theorem. That is the Pythagorean theorem. So if I want to find a missing side here, I could do what's called the Pythagorean theorem. Which is a squared plus b squared equals c squared. Now the key thing about this, guys, hypotenuse is the c. That spells hypotenuse. Trust me. The a and b are just the two sides. I don't care which one's which. C has to be hypotenuse though. So c is going to be this part. So in this case, I don't have my c. I do have my a and b. Doesn't matter which one's which. I'm not even labeling. Don't put a label on things. I have this. I get 9 plus 49 equals c squared. So 58 equals c squared. Square root of 58 is my c. So now I have everything I need. I have all the sides. So if I want to figure out what sine is, sine of b, so TOA, right? So TOA, you know I already have TOA. Is this going to be opposite of hypotenuse? We don't need to rationalize this. Cosine of b, would be adjacent over hypotenuse, 7 over rad 58. And then we could do all the rest. We could do sine goes to cosecant, so you just flip it, rad 58 over 3. Cosine goes with secant, so radical 58 over 7. And then cotan, well look, we already know what tan is, you just flip that, so 7 over 3. And that's the idea. So it's just like before, but now you have to do a little more work to make the triangle yourself. Once you do that, label the sides. This is tan, so opposite over adjacent. So opposite put 3, adjacent put 7. And hypotenuse is radical 58. And that's the idea. Now here we're going to use a calculator. So they want us to find the missing side. The key thing here is, step 1 is label your sides. And then we're going to do SOHCAHTOA to figure out which one you need. And then we're going to solve. So what do I mean by this? Let's label our side real quick. So here's my angle. This is opposite. This is right angle, so hypotenuse. This is adjacent. I'm going to write SOHCAHTOA because that thing's amazing. SOHCAHTOA. Now look at what we have. I don't have anything for the opposite, so that's gone. I do have adjacent and hypotenuse. Look at SOHCAHTOA. Which one's adjacent and hypotenuse? So we're going to use cosine for this one. Cosine of 60 equals adjacent over 14. X over 14. So, multiply both sides by 14. And you're going to get x equals, now let's put my calculator. Gotta turn this on. I get 14 times cosine 60. I'll tell you right now, this is going to be the wrong answer because I believe I have it in radians. Or I didn't put it in with them. Okay, whatever. I don't know what's going on there. Oh, I'm going to put 14 times cosine 60. So I get negative 13. That doesn't make sense, right? How do I have a negative side? What's going on here is I have this in radian mode. So if you go to mode here, default to radians. But for now we're doing degrees. How can you tell when you use degrees? There's a degree symbol. So it's kind of a big giveaway. So we're going to go over to degree, hit enter. Now it's in degree mode. Get out. I do the exact same thing 14 times cosine 60. Now I get my answer of 7, which makes a lot more sense. So that's all we're going to do. We're going to label the sides. You can do it in your head on the write it out. And then you go, okay, which one do I need? So SOHCAHTOA. Put that one and just solve it. So we're going to do the same thing here. Right? So let's label our sides. Here's opposite. Here's hypotenuse. Here's adjacent. So try to think SOHCAHTOA. Which one do I need to use? And if you look at, we're looking for hypotenuse and we have opposite. So OH, sine, my favorite. So you go sine of 45 equals x over 10. To solve this, you're going to multiply both sides by 10. And get x equals sine of 45. It's going to be some decimal. So 10 sine of 45. 7.07. If we round it in there's 2 decimal places. Since I'm rounding, I should put a little curly red. It's an approximation. So that's the idea. Ooh, one more. So same idea, right? Let's label our side real quick. Opposite. It's the same question. Let's go and do sine again. Sine of 24 equals 11 over x. Now this is a little different. Look at the math's a little harder. X is on the bottom. How do you solve this? The exact same way. Let's get rid of that x, multiply both sides by it. And then you get this. You get x sine of 24 equals 11. So we're going to divide by sine of 24. Takes an extra step, but it works the same way. X equals 11 divided by sine of 24. So about 27 degrees, roughly. About 27 degrees. So that's the idea. Next up, how do we find the angle? So we just found sides using our calculator, right? The sides are always missing. What if we flip it though? What if we find the angle? Well, there's a button in our calculator keys for this. That's called inverse trig functions. So if we want to get rid of sine, if I have sine of a equals like, let's say 1/2. If I want to get rid of it, we're going to do what's called inverse sine. So we're going to take the inverse sine of both sides. Sine -1, sine -1. Inverse sine, just for you to know, is also known as sine to the -1 power, is also known as arc sine. Don't ask me why. Same thing goes for all of them. Instead of writing cosine inverse, you could write arc cosine. The same thing for tan. So these are the exact same thing. And how I do this, I put this in my calculator. So if you look at where sine, cosine, tan is, in my case light blue, you can see the inverse ones. So in this case I put inverse sine of 1/2. Now I get 30 degrees. So this is just a equals 30 degrees. Notice it's a because the sine cancels out. So a equals 30 degrees. The one down here, same idea. I want to get rid of the cosine, so let's do cosine inverse of both sides. Or arc cosine. These cancel, you get a equals cosine inverse 319. So second cosine, 3 divided by 19. 80.9 is what I saw. So 80.9 degrees. And then same thing there, do tan inverse, blah blah blah. We got the gist. And then again, we could parlay it to what we've been talking about earlier. So if I want to do this, remember the same steps. You go, here's my angle. This is the sides. Opposite, hypotenuse, and adjacent. And again, SOHCAHTOA. Right? Look what we have. I don't have that. I have adjacent, I have hypotenuse. Don't have that. So ka. Don't have that. So SOHCAHTOA, so cosine of x, equals adjacent or hypotenuse. So you're going to get rid of cosine, so it's inverse cosine both sides. These cancel, and your answer is going to be whatever cosine inverse of 15 over 17 is. So second cosine, 15 over 17. So 28.1 about. So x is roughly 28.1. Right, and real quick to do this. Right, opposite. hypotenuse, and adjacent. And look at that one. I have opposite and I have adjacent. I don't need hypotenuse. So opposite of adjacent is TOA. So tan of x equals opposite over adjacent. Do tan inverse of both sides. 27 over 18. I believe it was that. And I got 56.3. Hey, it was. Okay, almost done. Now let's apply both of these techniques to an application problem. First up, we have to talk about angle elevation and depression is. So here's the key thing a lot of people mess up. And actually, I want to erase this part real quick. Let's go a little faster than that. Behind these things. There we go. That's an erase. So when we talk about angle elevation and depression, the key thing to keep in mind is that it starts from a horizontal line. So here we go. The horizon. All starts from a horizontal line. Actually, most of the time I draw an eyeball to show you like it's all about your perception here. So let's draw. Here's my eyeball. I don't know what that is. But so that's gonna give me nightmares. Anyway, there's a horizontal line, and the angle above that horizontal line is elevation. The angle below the horizontal line is depression. I bring that up because a lot of people get lazy with depression. They're like, oh, depression. So they'll do this and they'll give it that one. And they'll give the angle that's connected to the right angle. That's not good. Horizontal line, draw a straight line, and then above it elevation, below it depression. If you get that, you're going to be fine. So this is an example here. A ramp for unloading a moving truck has an angle of elevation 32 degrees. If the top of the truck is 5 feet above the ground, estimate the ramp length. So they want us to find the length of the ramp. Here's x. If the top of the ramp is 4 feet above the ground, so they're saying this is 4. And they're saying the truck has an angle of elevation of 32 degrees. So here's my straight line, the floor. This is 32 degrees. So if I just redraw it, this is x, here's 32, and they're saying this is 4. So we can do what we've just been doing. So got TOA. Ooh. And look what we have, right? This is opposite, this is adjacent, this is hypotenuse. I want hypotenuse, I have opposite, that is OH, that is sine, my favorite. Sine of 32 equals 4 over x. We're going to multiply both sides by x to get x sine 32 equals 4, divide by sine of 32, and you get x equals 4 over sine of 32. You just put that in your calculator to get an answer. Last one. The recommended angle of elevation for a ladder using a firefight is 75 degrees. At what height of the building does a 21-foot ladder reach if the recommended angle of elevation is used? Round to nearest 10. So let's draw a little picture here. My building. I just wanted to make it worse for you guys. That's all that was there. Right, and it's on fire. And then our firemen coming to put like a fire ladder up. Here's my fire ladder. Now look what it says again. The recommended angle of elevation for the firefight is 75 degrees. So this has to be about 75 degrees to be stable. At what height does a 21-foot ladder reach? So this is a 21-foot ladder. So this is 21 feet. If we're looking for how high in the building does it go? If that angle is 75. So this is what we're looking for. So again, I'm going to just draw another triangle on the side here. 21, 75, and x. List out the sides. This is opposite. Here's right angle. Here's hypotenuse. And this is adjacent. We want opposite. We have hypotenuse. That looks like so. Sine again. Multiply both sides by 21. Actually, want to see this one. I'm curious. Sine of 75. Now notice, like in this case, I got to close my parentheses. I don't want 21 being part of this. Times by 21. and I get about 20.2. It's about 20.3 feet is the answer. It goes about 23 feet high. It's kind of interesting.